So good afternoon everybody. Today I am going to tell you what is a tool of quantum mechanics. This understanding of quantum mechanical tool is very essential, and this tool of quantum mechanics deal with the representation of wave function in Dirac form and Hilbert space. First of all, we have to know Hilbert space. What is a Hilbert space? So Hilbert space is a linear n-dimensional space where vector addition rule, vector multiplication rule hold. Okay. And we often representation wave function in terms of bracket notation in Hilbert space, but it will physical meaning will remain same. So what is the representation? First, wave function, we suppose this is a system, n numbers of particle is there, n number of particle of a system. We often represent this wave function is represented by suppose phi. Suppose phi we represent as a a1 phi 1 plus a2 phi 2 dot an phi. In the last class, in the last quantum mechanical class, I have told what is the meaning. These are the possible microstate where this wave function stay. What wave function means? It represents a system of n particle. Maybe a single particle. For example, particle in a 1D box or particle in 3-dimensional box. Okay. These are the in statistical view. These are the microstate. Suppose this is some wave function representing Anil Hazarika. Anil Hazarika can stay in Jorhat, Guwahati, Tezpur. This is a possible microstate of me. Okay. And if we represent in terms of a Dirac form, then how will I represent this? This is called cat vector. Okay, cat vector. Then I want simply write as this one. I will write a simple form. This a2 dot nothing else. Representation of this wave function in cat form, it will not change anything, just only representation that we have to understand. So sometimes in net gate question it may give like this or it may give like this. If they give like this, we can transform to this one. It is not without any changing the wave function. Just put the cat form in place of this one, and vice versa. Similarly, if I write this is called bra vector. Okay, this is bra, and this is called complex conjugation of this wave function, or nothing else, just complex conjugation. When you take the complex conjugation, then you remember, then A is maybe complex, maybe real number, we don't know. That is why I put complex conjugation number. If it is real, then no need, but I don't know right now, that is why I am writing here. But then it is phi 1, and similarly, this is phi 2, and phi 2 goes like that plus an star phi. Okay, this is a simple representation of a wave function of a n system of n particle in terms of bra and cat. Okay. So simple example, I am giving an example. Suppose this wave function, suppose this is a cat vector in Hilbert space of a wave function. Then if it is this wave function is I phi, suppose, then this bra vector is equal to the e to the power minus I phi. Okay, this is nothing, just complex conjugation of this part. Okay. Then we talk about the normalization. This is a basic normalization condition. Okay, what is a normalization condition? We have already studied in the previous class whenever we talk about the postulate of quantum mechanics. So normalization, we often write psi star psi dx. It is one-dimensional. If it is three-dimensional, I can write it in dq bar. Okay, this is a normalization condition. It is equal to psi star psi. Okay, and this is represented as a psi comma psi, and this is called norms of wave vector phi. Okay, this is sometimes it is called norms, and sometimes it is called normalization condition. And this is C. This phi star is represented by this part. Okay, phi is represented by this part, and this is nothing, just integration. And limit will be as per the problem. And it is known as a scalar product. It is known as a scalar product because this will give a scalar quantity. Suppose if it is normalization, then it will be 1, and it may not be normalization, then whatever it is, but it will give a scalar quantity. Okay. Now the important properties. and this is very important, you have to understand. Otherwise, whenever do a operator calculation, you often get confusion, because 2-3 question often comes from this part. Okay, and every question, you remember one thing, every question comes in a net gate exam is everything from the Zettili book. And Zettili book, a numerous number of problem, a large number of problem has already been solved in the Zettili book. If you solve and if you understand, I hope there will be no confusion. And this is the sector number 2 of Zettili book. Sector number 3 I have already teached you. Okay, then important property, every cat, this is a cat vector, there is a corresponding bra vector. This is a bra vector, this is a cat, this is a cat, this is a bra. Okay, every cat has a corresponding bra and vice versa. Okay, then if I take A1, suppose A1, this is A1 phi 1, A2 phi 2. This is in basis vector of any wave function in terms of cat vector, and it will have a corresponding bra. This is both direction means vice versa. You can, every bra has a corresponding cat, or you can say that every cat has a corresponding bra. So I will write A1, this is star, okay, phi 1 plus A2 phi 2. Clear? It is complex conjugation. When you transform from bra to cat, always remember everything will be complex conjugation. This is a coefficient, okay, then it will be complex conjugation. Then number 3, this is number 2. Number 3, if I take a operator calculation, operator calculation A equal to suppose A1 phi 1, A2 phi 2. Okay, this will happen, what happen, equal to the, this A is a constant, A is a operator, capital A is a operator, small a is a constant, it will come out, small a will come out, then it will operate on a particular function. Okay, clear? This is the basic property of property. Number 4 property, I am writing here. Number 4 properties. Suppose if I operate, this is suppose A1 phi 1 equal to A2 phi 2. Bracket A is the operator, B1 phi 1 plus B2 phi 2. Okay, if I take the product, then always remember this A is the operator. It may be momentum, it may be energy, whatever, we don't know. This operator will operate on a particular this function, not this function. Okay, then you can do one thing. This is a complex conjugation. A1 will come out, is a complex conjugation phi 1. Okay, this is A2 complex conjugation phi 2. Clear? Then this operator will B1 is a constant. B1 will come out. Then operator here phi 1, and B2 is come out A phi 2. Clear? Now you take the normal product. You take a normal product as for this part with this part. Okay, this part will give A1 star, okay, B1 phi 1, okay, operator and phi 1. Clear? Similarly, this part with this part, this A1 star, B2 phi 1, A phi 2. Similarly, plus this term with this term, A2 star phi 2, B1 and A phi 1. Okay, and then this term with this term, A2 star B2 phi 2 A phi 2. Okay, this way you have to take the product. Okay, now I think I hope you understand. Suppose another example, operator calculation, or another example I am giving you. Suppose a to the power wave function, suppose this one. A is a suppose exponential operator and equal to suppose e to the power suppose a equal to e to the power a. Then you have to write suppose b operator. I am giving a b operator. Then it will be better. Then this expression is like that. So b is a operator which is a exponential operator. I can transform to this, and suppose then if I exponential part, if I expand it, suppose we know the e to the power x equal to 1 plus x factorial 1 plus x square by factorial 2, something like that. It goes like that. So it will be a plus a square by factorial 2 dot 5. Okay, then this I 5. Okay, next one will be a 5. Next one will be a square by factorial 2 5, and goes like that. Then a to the power n by n factorial 5. Okay, now suppose this is nothing, unitary vector. This is I operator, unitary operator. It will remain phi vector. Eigenvector is 1, unitary operator. This will give you a operator. A is eigenvalue of a operator. Then it will 1 by a square by factorial 2 phi vector, and then a n square a to the power n factorial 5 n factorial 5. Okay, clear? So after that, after operation, we will get the eigenvalue. That is why I am in place of a small a is nothing. Don't think that small a is an operator. Small a is an eigenvalue of capital A operator. Capital A is any operator. It may be momentum operator. We don't know. Okay. So now we will discuss a small question. Then you will understand. You will understand. Suppose you see. Suppose a phi vector is represented this question equal to ti phi 1 minus 7I phi 2. Okay, this is the wave vector. Calculate the phi 1 and another vector phi chi vector is represented is equal to minus phi 1 plus twice I phi 2. This is. Now calculate this one. Calculate phi plus chi cap. Find this value. This is nothing. Phi plus cap means you have to add like this, phi plus chi. Simple addition. Now you add this part with this part. This part will give you how much? It will give you thrice I minus 1 phi 1, and this part simple addition. Only corresponding term you have to add. This one add with this one, this one add with this one. Okay, then it will be minus pi by and pi. Clear? Simple. Next you have to calculate. Next you have to calculate this one. What is the value of this one? Phi chi. Okay. When you talk about phi chi, this is a bra, this is a cat. Cat is already given. Bra is not. This is a cat. Bra is not given. So we have to transform. This is, if we transform to, this is a bra cat form. If we transform to bra form, it will be minus ti phi 1. Okay, and plus 7I phi 2. Okay, and then take the product with this one, minus phi 1 plus twice I phi 2. Okay, this is now you multiply with this one, or now you like a vector addition formula. Suppose if you cross, what happened? K dot r. K dot r means this is kx I plus ky z plus kz k. Okay, into dot product of xi yz plus zk. But we will do in vector product. We will product with this term only. We'll product with this term only. We'll product with this term only. 3 term we are going to product because I dot I is 1, I dot j is 0. Similarly, I dot k is also 0. That's why I am not going to consider. Here, similar calculation is also there because as per normalization condition, phi 1, phi n, phi m is equal to delta nm. Okay, suppose this is phi 1 into phi 2, it will give what? 0. So that is why we have phi 1 with product with phi 2. Okay, phi 2 product with phi 1. Rest of the term we delete it. No need to have it because it will consume time. So it will have a, this is minus 3i minus, so plus 3i phi 1 phi 1. Clear? Then this is 7i and twice i. It will be how much? 14i square. 14i square, then phi 2 phi 1 phi 2. This is equal to 1 as per normalization condition. This is a normalization condition. While this is 1, this is 1, then 1. It will be, if it is 2, this is 1, then it will be 0. So this will be 1 ti plus this is 4 minus 14. This is the answer. This way you have to evaluate it. Okay. Now one question comes in the net exam. Net exam is the wave function of a system. Wave function of a system is represented as 1 by root 2 phi naught plus I phi 1. Okay. And phi naught is the ground state energy, ground state wave function, and energy eigenvalue is E naught. And phi 1 is the excited state wave function, energy eigenvalue E1. Okay, I am telling the question again. This question comes in the net exam 2017. Okay, a wave function of a system. Wave function of a system is represented by this one. Okay, phi naught is represent ground state with eigenvalue E naught, and phi 1 is the first excited state wave function and eigenvalue E1. Okay, what is the expectation value of momentum? Hamiltonian. Hamiltonian expectation value means energy, total energy of eigenvalue. So, what do we have to do? This is part I am removing. Now I have to calculate the expectation value of Hamiltonian. Okay, we know this formula. So Hamiltonian is the operator. Operator is equal to energy. This is a Schrodinger time dependent equation. Okay, Hamiltonian is the operator. This which represents total energy of a system, and E is the eigenvalue. Okay, Hamiltonian means energy eigenvalue. So what is the expectation value formula? We have to calculate. This is the formula. This is the expectation value calculation. Psi is psi. Clear? So what is, now we have to, this one we have to calculate. So what is the calculator? Psi 1, psi is equal to this one, 1 by root 2 phi naught. This is in cat form, I phi 1. Is it okay? And phi, capital phi is equal to 1 by root 2 phi naught. This one will be complex conjugation. I have told you the coefficient will be complex conjugation. This will be minus I phi 1, this one. Okay, if we take this product of this wave function, then what happens? If we do the product, n psi 1 into psi, I am removing this part again. Now I am writing this side. Okay, I think it is visible from that side. Phi naught plus I phi 1. This is okay. Now if I take this phi and phi, because this is, I have to calculate expectation value. This is the formula expectation value, because this wave function does not tell about the whether this wave function is normalized or not. If it is normalized, then this part not necessary, but the question does not tell the wave function is normalized. Okay, that's what I have to find out. Then what is the value of this one? This equal to what? This part I have to read first. 1 by root 2 phi naught minus I phi 1. Clear? Close. Then this part I have to remove it. I am removing this part. Then this part 1 by root 2 phi naught plus I phi 1. Simple. Take the product. Simple part. This one product of this one and this one is 0 because as per normalization condition, we will get, if we product this term with this term, whatever the, forget about the coefficient, this term will get 0 and this term will get 1. So it will be 0. As per normalization condition is what? Psi n equal to delta n. If it is n, if n must be equal to m, then this is delta function. It will be 1 only when n equal to m, otherwise 0. Okay. This is what? If we take this one, how much? 1 by 2 phi naught. Is it okay? This is what? Minus I. So it will be minus I square. Minus I square means 1. So it will be 1, phi 1. So it will be how much? 3 by 2. Clear? So that means this function, I am removing this function. This is equal to 3 by 2. Then I have to calculate this part. This part I simply write this one. I am writing again. This part I am directly put the value, and this part is this one. This part I have already shown you, 1 by root 2 phi naught. I am writing this part, okay? Phi naught minus I phi 1, okay? Then Hamiltonian, okay? Then this is close bracket. Then I am writing close bracket this part, 1 by root 2 phi naught plus I phi 1. Close bracket. Now you see, this is 3 by 2, right? And this left hand side will remain same. Forget about that. The right hand side, think that this operator will operate distant and also distant. If this operator operates on this wave function, then I am writing this is x. Okay, this part will remain same. That's why for simplicity I am writing x. X into is this part operate on this function. This is what? Ground state wave function. Then they have already told that ground state wave function has the eigenvalue E naught. So whenever this operator operates on this function, I will one step I will write here. 1 by root 2 will come out. Clear? And A is phi naught. Then I will come out A is phi 1. Clear? This part I am representing x. So x means this part, 1 by root 2 is there, and when this Hamiltonian is an operator on a ground state, it will give a eigenvalue which is equal to E naught. Okay, E naught phi 1 will be remain same. Okay, don't forget to put this equal to I, E1. This when a Hamiltonian operator on first excited state, then eigenvalue is E1. Already this information given in the question. So phi 1. Okay, if you do this calculation, finally you will get this value. This below is 3 by 2, and this term with this term, how much? Half E1, E naught plus E1. This is the energy of eigen. Okay, this question carry 3 marks. Okay, simple question, don't worry. Then Hermitian operator. What is a Hermitian operator? Hermitian operator. Hermitian adjoint. A operator to operator Hermitian operator, the matrix Hermitian operator means, I have already told you, operator means physical variable means matrix, don't forget. Okay, any operator is called Hermitian operator if a dagger. This is called dagger. Dagger means this is dagger equal to complex. Suppose a dagger equal to a complex conjugation and transpose, or you can say a transpose then complex conjugation. Okay, clear? And now, or we can say this is if a operator or matrix equal to dagger of that operator, then it is called Hermitian operator. Hermitian operator, eigenvalue of Hermitian operator must be real, always remember, and diagonal element of Hermitian operator must be real. So if this AM, so this part I will discuss later also. Suppose in matrix form A and M, you have no A and M means I am always writing A11, A12, dot 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 A1M. Clear? Similarly, it will A21, A22, dot dot A2M. Last one A NM, N1 equal to A NM. So what actually telling that A and M means matrix element. This is A11, A12, A37. So Hermitian matrix, this diagonal element must be real first of all, and you can say this statement. You can say A and M equal to A M and complex. If this is satisfied, then it is Hermitian. For example, I am giving an example so that you can easily understand. I am giving an example. 1. See, a matrix is given as is 2I0 minus I 1 1 0 1 0. This is a matrix. I have to ensure whether this matrix is Hermitian or initial statement. You can test it. Diagonal element must be real. Is it okay? This is already okay. This is Hermitian matrix. Second is that according to Hermitian condition, A is equal to A is Dagger. Dagger means you take the complex conjugation of matrix. You check the complex conjugation. Complex conjugation, it will be minus I 0. This is I 1 1 0 1 1. It is complex conjugation. Okay. And now transform the complex conjugation. Complex conjugation, take the transform. Equal to what? This will come vertically. 2 minus I 0. This will come this way. So I 1 1. Next 0 1 1. Or it is 0. You see, this is equal to what? Matrix A. Matrix A is. So this is Hermitian. Or you can say it. This is overall experiment of the matrix. Okay. Another example I have already told you. A and M equal to A star NM. What are equal? Suppose A11 element, 1 3 element equal to A31 element star. Is it okay? Second. 1 3 element. This is A11, A12, A13. Okay. A13 equal to A31. Is it okay? Clear? 0 0 maths condition. Elemental analysis. This is called elemental checking. Okay. If you forget, then you can check. Suppose this is what? A11, A12. A12 must be equal to A21 complex conjugation. See, A11 equal to how much? This is one equal to I. And this element equal to how much? Complex conjugation of A21. A21 means this element. So minus I, complex conjugation of I. So that means this matrix is Hermitian. This way you can also verify. Okay. And if it is not, suppose A equal to minus of A dagger. Dagger means complex conjugation and transport of matrix. Then it is called skew Hermitian or anti-Hermitian. Eigenvalue of anti-Hermitian either real or 0 or imaginary number. Eigenvalue. Suppose in reverse way we can say that suppose eigenvalue of any matrix, suppose one is 0 and twice I 1, suppose 3 by 3 matrix. Whether somebody asks you whether it is maybe Hermitian, no, it is not Hermitian, it is anti-Hermitian or skew Hermitian. Okay, because I is there. Another example, Hermiticity can this is very very important for net exam. Net exam or gate exam, this question comes. And see which of the following is operator is a Hermitian. Hermitian. This is the given. So what is the condition of Hermitian? Hermitian operator, if A operator is equal to A dagger, then it is Hermitian. So we have to check it. Why dagger equal to how much? A plus A dagger. Dagger. Okay. A dagger means A dagger plus A dagger. And if you remember, A dagger dagger equal to A. So it will be what? A dagger plus A equal to Y. So it is Hermitian. Y dagger equal to Y, that is why it is Hermitian. Similar way, another example you can say. Similar way, and more examples. Suppose if I say this example, this one, whether this is Hermitian or not. Suppose then I have to take the dagger. Dagger equal to I A plus A dagger equal to I dagger means I imaginate the number means I dagger means transpose conjugated because it is a single element, so there is no transport. This does not have meaning for single element. So this for this one it is only complex conjugate. Minus I A dagger plus A dagger per dagger. So equal to how much? Minus I A dagger plus A. This is equal to how much? Minus Y. Is it okay? It is Y dagger equal to minus Y. It is not Hermitian. It is co-Hermitian. Okay. This way we have to say. So many of example I am skipping here because due to time, so that you can understand. Projection operator. Projection operator you study. Projection operator means if P dagger equal to P and P square equal to P, then it is called projection operator. You carefully study the chapter number 2 of Zettili book, Rule of Quantum Mechanics. Now we are going for commutator operator. Commutator. What is a commutator? Commutator means what? We often write in a commutator relation. It is represented B. Okay. It is often states the commutator relation. Okay. Equal to commutator is equal to 0 means, what do we mean by that? 0 means if a commutator of two physical variable or operator or observable is 0 means we can measure that quantity simultaneously and with desired accuracy. If two commutator is 0 means we can measure A operator, B operator simultaneously. In quantum mechanics we often write this expression x px equal to I is cos I. I is the unit vector. This is a matrix, that's why I put I. Okay. Or you can simply put I is cos. What does it mean? This commutator does not 0 means we cannot measure x position as well as momentum operator with desired accuracy. Okay. This is the meaning of commutator. So another meaning, this A commutator AB. Commutator AB is equal to 0 means what? Commutator relation AB means what? AB minus BA equal to 0. So that means AB equal to BA. What does it mean? Normally what happens, this is nothing, just matrix product. AB is a operator. Operator means matrix. So AB normally in matrix, if you say normally in matrix AB not equal to BA in matrix, normally not equal. Okay, it will be equal only when if each element of A must be equal to the corresponding element of B. That means if A element of A must be equal to the corresponding element of B. That means every element must be equal. Then it will be equal. Otherwise, normally matrix operator, this AB not equal to BA. Okay. Next, this is the physical meaning. And another physical meaning I am telling you, suppose AB equal to 0 means, this is AB or 2 operator, physical operator or measurable quantity. If commutator of this equal to 0 means, these two parameter, two operator will have common eigenfunction. Suppose, if first consequence, if it is 0, then we can measure simultaneously with desired accuracy, number 1. If it is not 0, that means we cannot measure the quantity which desired accuracy. Clear? If it is 0, that means these two operators have common eigenfunction. Eigenfunction, suppose if I consider, suppose this is eigenfunction, basis vector. This is basis vector of suppose A, and this also basis vector of B. This is known as a common eigenfunction. Okay. Then do one problem, then you can easily understand. And another third consequence is commutator A and corresponding commutator is always 0. If any operator or matrix, this is A with its own operator is always 0, remember. And third one, this is the properties of commutator. Third one, A with any constant. Suppose C is A is a constant. Any constant is always 0. Commutator of any operator with any constant is always 0. And suppose another example I am giving is I is a unitary operator, is a constant, is always 0. So clear? Functional operator. The anti-commutator is represent. This is anti-commutator. This is anti-commutator relation equal to AB minus BA. This is anti-commutator relations. Okay. Commutator is, this is commutator relation AB. Anti-commutator is represented by middle bracket. Always middle bracket. Now okay. And another example, suppose A is A equal to momentum operator. If and AC is, suppose B is equal to a Hamiltonian, is a total energy. This is also Hermitian, this is also Hermitian operator. Then there will be product is also Hermitian operator. Remember, this is the condition. Hermitian operator means, what do we mean by that? Hermitian operator, I am telling you again, if A operator is Hermitian and B operator is also Hermitian, then product of that operator is also Hermitian. That means this one. Hermitian operator means AB dagger equal to, it is, when it is dagger product, it is always represented in reverse order. Always remember. Dagger equal to B and A. Okay. B is Hermitian, that is why B dagger equal to B. A is Hermitian, A. That means what? Whole this is a suppose single operator. AB product is single operator equal to B is a Hermitian. So that's what I am telling you. Okay. One example you told. Functional operator commutator. Functional commutator operator. Functional operator and commutator. This is very important for exam because last 2-3 years continuously asking question on an operator and commutator. Functional. What is this? Suppose AB is not equal to 0. 0 means, but you understand, if A and B two are physical operator and they are not commute. Commute means we cannot measure these two quantity accurately. Okay. Then what happens? Suppose fa, any function, suppose e to the power a, exponential function. Yeah, I can expand is it I plus a square factorial 2 like that. So this is a function, arbitrary function which depend on a. Okay. Then what happens? If ab is not commute, so function of a and b is not equal to 0. Remember. Clear? Again I am telling, if two operators do not commute, then they also do not commute with any function that depend on either a or b. Clear? So in that case, this is clear. And one question asked in a net exam. This question comes in a net exam. I am giving you so that you can understand. And another example is I am telling you. AB, another operator principle, AB equal to minus BA. This is the principle, reverse order, minus. And this is the third. And third condition, e to the power A into e to the power B. Don't think that it is, we have already studied e to the power m into e to the power n equal to e to the power m plus n. Normally it is in algebra. But here it will not equal e to the power A plus B plus half commutator AB. This is the example. This relation is often asked in the exam. Why? Because normally everybody do like that, e to the power A into e to the power B equal to e to the power A plus B. But this is true. E to the power A equal to e to the power B, A plus B, it will have equal to this one. Only when, under which condition? When two operators commute. Again, if I say that if two operator A, B commute means A, B equal to 0, then e to the power A into e to the power B equal to e to the power A plus B. Then commute means A, B equal to 0, this part will 0. So under that condition, this is correct. Otherwise, e to the power A plus B equal to this one. Okay. So another operator properties. Suppose number 5 properties A, comma B plus C plus D. Suppose it is, suppose the expression is like that. How can you expand? First this one with this one, first this one with this one, first this one with this one. So simple, AB plus AC plus AD. This way you have to do the calculation. Okay, simple way. And number 4, suppose AB dagger. If you do this calculation, then B dagger, comma A dagger. Okay. Number 5, ABC equal to AB. First these two terms, AB, C will come out, then B will come out, B, AC. See how it is, AB, C will come this side. Now B is the middle, it will come left side. This is it. Okay. Now one question is given that under which value of this, you listen the carefully. Question, exam, this is comes in the exam. If a operator E equal to e to the power alpha A, okay, suppose B, if operator is this one, and for what value of alpha, this B operator is Hermitian. Can you tell me Hermitian? Under what value, for what value of alpha, this B operator, this is I think oh no, this is alpha. So B operator will be Hermitian. We have to say B dagger. So how will you do? B equal to e to the power alpha A. So A is already Hermitian. In the question it is mentioned A is also Hermitian. So B dagger equal to how much? E to the power alpha A dagger. C is equal to e to the power alpha complex conjugation. Alpha complex conjugation and A dagger. A is already Hermitian. E to the power complex conjugation A. Okay. Now you think if alpha is a real number, then complex conjugation does not have any value. So it will happen e to the power alpha A. So that if it is suppose minus, then it will be complex conjugation. It will be suppose complex number I, say imaginary number. Then it will be plus I. So it will change the property. So that is why only alpha is a real value. When alpha is a real, then this operator will be Hermitian. Otherwise it will not Hermitian. This question comes in the exam. Suppose I consider this is suppose I consider B equal to e to the power alpha equal to IA. Okay, imaginary number. I consider I is imaginary number. Then B dagger equal to how much? B dagger equal to e to the power IA dagger. Dagger means complex conjugation, but it is a number. There is no complex conjugation and transpose of matrix. Transpose does not have meaning for a single number. It will have e to the power minus I A dagger. A is already Hermitian, so e to the power minus IA. Okay, e to the power minus IA means what? So B inverse. So it is not satisfied. So B dagger equal to B inverse. So it is not Hermitian. So for alpha value for complex number, it will not be Hermitian operator. This question comes in again. Then we will do one problem. These two problems, then I will finish it. Okay. Because it will, and I will take one another class and so that to complete all the part of this chapter, tool of quantum mechanics. So first of all, I will discuss the net question. So this question comes in the net exam. So carefully think. If question you read carefully, if AB not equal to 0, okay, and AB equal to I, unitary vector, okay, and e to the power A equal to I plus A square by factorial to something like that, A cube by factorial t, dot. And find this value of e to the power A B. Find the value. How will you find? So you have to find this value. So I will put here left hand side. So it will be better e to the power A B. We have to find out the value of A. Okay. So what will be the value? E to the power A equal to, I will expand exponential form, I plus A square by factorial 2 plus A cube by factorial t. Clear? Dot into B. Okay. Now I have given one example. A commutative property C plus D plus F. Then what will happen? AC plus AD plus AF. This way we have to expand, right? This is the property of commutator. So I will expand IB first term. Next term will be AB. Okay. Next term will be what? 1 by factorial 2 A square B. Okay. Next term will be what? 1 by factorial 3 A cube B. Right? Now I have to give you another properties. A to the power n B equal to what? Can you remember this formula? This is suppose differentiation. N AB no need to write n. Okay, it's just differentiation of that part. Suppose I am doing the differentiation, d to the power d x to the power n. So what will have n x to the power n minus 1. Same way we have to do n a n minus 1. This is the differentiation. Okay. So first term will be what? Because this is a constant b operator, first term is 0. Second term is what? This term already given I. Third term 1 by root 2 a square. This is 2 into a 1. Third term 1 by 3 factorial. This will be 3a square. Clear? So it will be I plus a plus, this is factorial 1 cancel, a square by factorial 2 dot equal to, this is what? Equal to e to the power a. Is it clear? This question comes in the net exam. I think it is 5-mark question. Similarly, another example. This also comes in the net exam. This formula I have not given. This formula you have given, you remember. A to the power n b equal to, just differentiation. Remember this differentiation. X to the power n. So n x n minus 1. Same way here. N a n minus 1. And unit vector you can represent it, not necessary unit vector. Okay. Similarly, if I do a b n, then I have to n b n minus 1. This is the property. Always remember. So another example, this also comes in the net exam. You can, if you take the question paper of net exam, you will find if x px equal to I is cos equal to I in is cos unit. Okay, this is equal to I is cos equal to I in is cos unit. Okay, find the value of x p e to the power minus p. Can you find the value? So I have already given one example, a b c. So it will be what? A b C plus BAC. This property of commutator, I have given you this formula, and using this you can expand xp e to the power minus p equal to what? Xp e to the power minus p, then x e to the power minus p. Is it clear? And after that xp equal to I already given. First term will be easy, so I e to the power minus p first term. Second term will be p x into this one. The second term it will be I minus exponential this is e to the minus x p plus p square by factorial 2 minus p cube by factorial 3 goes like that. Okay, goes like that. So it will first term will be I e to the power minus p. Next p, this first term with this one x I. Second term will p is already there. Okay, second term is x minus p. Next term will be x p square by factorial 2. Next term this will be minus, then x p cube by 3 factorial. Okay, minus you can take it outside, no problem. Minus you can take it minus here you can put. This way you can expand. This is what xpx, simple. This part is defined x p square by 2 factorial. This means what? X half, it will come out the 1 by factorial to xp square. Xp square is equal to how much? I have given a formula a b n b n minus 1. So it will be what? This way you have to expand. It will give a answer will be I 1 minus p into the power minus p. I am not going to do calculation. Okay, this is how you have to do the calculation. Okay, and now how I want to tell you a simple important representation and last term. Okay, trace of a matrix. I want to just give you a hints, important thing. I will, and rest of the things I will discuss in the next class. But one more important things I want to give. One more important things I want to give you. That is a trace of matrix. So trace of matrix is what? Matrix. So trace of a matrix, suppose A is a matrix, suppose A11, A12, ANM, okay? A12 dot A1M. Is it clear? A21, A22 dot A2M. ANM, NM1 dot AMN. Is it clear? So trace of a matrix, A matrix, ANM equal to sum of all diagonal elements. Sum of all n diagonal element. 1, 1, 1, 2, 2, 3, 3 like that. This is diagonal element. And trace of a matrix. This is a one property. Okay. Suppose another telling you. Suppose A is a square matrix. A is a square matrix. 3 by 3 square matrix. Okay. Remember, this is very important for quantum mechanics as well as statistical mechanics. If A is a square matrix, 3 by 3 matrix, the eigenvalue three eigenvalue I will get A1, A2, A3, and basis vector is 1, basis vector 2, basis vector 3. Number of basis vector according to the number of eigenvalue. Okay, I am telling you again, if A is a square matrix, it has a 3 eigenvalue A1, A2, A3. Okay, and 3 basis vector. Then what is the exponential matrix? Can you tell me what is the exponential matrix? This is because very important. Then this will be nothing, just e to the power lambda A1, 0. This is suppose diagonal matrix. Okay, this is suppose diagonal matrix 0, 0, 0 e to the power A2, 0, 0, 0 e to the by AT. Remember, why diagonal? Because the eigenvalue of Hamiltonian matrix or square symmetric matrix is the diagonal element of the matrix. Okay. And suppose if I need a e to the power into ln a matrix, then what is a e to the power ln logarithm matrix? It will be remain same. Always remember e to the power ln a 1 0 0 0 e to the power ln a 2 0 0 0 e to the power ln a t. This is the square matrix. Okay. Why this is I am telling you this matrix. So far in quantum mechanics or statistics, I have given you the partition function. But partition function I have not represented you the matrix form. Suppose I have given you partition function in terms of e to the power minus beta here. Okay. But I am not telling the partition function e to the power beta a is a matrix. I have shown you. See, I am again giving you an example. A is a matrix. T by T matrix. Suppose T by T matrix A1 0 0 0 A2 0 0 0 AT. It is a diagonal matrix. So eigenvalue will be the diagonal element of square matrix. So T eigenvalue A1 A2 AT. Okay, I am telling you again. E to the power A matrix will be nothing, just e to the power A1 0 0 0 e to the power A2 0 0 0 e to the power AT. Okay. So similarly, this matrix is for exponential matrix. So partition function in matrix form, always remember. Partition function is matrix form. Matrix form, you can trace of e to the power minus beta. This is the partition function. Trace means this matrix means trace of. This is exponential matrix e to the power minus beta e1 0 0 e to the power minus beta e2. Is it okay? This is a partition function of two-dimensional system, or sorry, a system of two energy state. Then we will let the partition function for a system of two particles e to the power minus beta e1 plus e to the power minus beta e2. Is it okay? And this exponential matrix I can express in the exponential matrix e to the power minus beta a, e to the power minus beta a, and diagonal element is the partition function. Okay, this representation is the representation. I have already told you partition function in continuous form, partition function in discrete form, partition function in matrix form. This one you can check this example already given in statistical material book 109 page. Okay, this question is very important because many questions related to this exponential form has been asked using Pauli matrix. What type of question asked? You see, I am giving you means so that you can easily understand. And why I am telling you this all parties including mathematical physics, matrix and algebra, matrix and tensor. But before going to that part, I am giving you hints so that you can easily understand that mathematical part. So in one question, I am not going to do that. This question comes in the NET exam often many times. Consider electron a spin half. Consider electron, a system of electron spin is equal to half h cos sigma. Sigma is a Pauli matrix. Okay, and Hamiltonian of the system is given by mu b sigma dot b, where sigma z is equal to mu b Bose magneton, sigma z, and sigma z is a Pauli matrix, is given as a 1 0 0 minus 1. Okay, then if you put this value, then what will you get? Hamiltonian in terms of matrix form Hamiltonian, what will happen? Mu b e to the power minus mu b sigma mu b and 0 0 mu b. Okay, this is representation of Hamiltonian in magnetic field. Okay, in matrix form. Then what is the partition function? Now this question comes in the exam. Calculate the partition function of this system. Then it is very easy. Partition function trace of Hamiltonian. Is it okay? Trace of trace of e to the power minus beta e. Trace of e to the power beta e means Hamiltonian means total energy. So is partition function will be what? In matrix form, e to the power minus e to the power plus mu b by kt 0 0 e to the power minus mu b kt. This one in matrix form. This is matrix form in partition function. Always remember. and this is partition function. Is a trash means diagonal element, it will be represented by partition. This question comes in the NET exam, and you can check this is already given in statistical part 3 book 109 piece. Okay, already solution is given. Okay, that means what I am going to tell you, every question, whether it is quantum, whether it is statistics, or everything question comes from this specific books. Quantum mechanics, Zettili, statistics, Patria, Feddegrave, thermodynamic Feddegrave, mathematical physics, complex variable swarm series, this way. Okay, that's why I'm going to tell you that one thing, you strictly follow this book. Okay, thank you.